When we think about the destructive power of storms, we don't have to look much farther than our own backyard. Connecting the Kitsap Peninsula to Tacoma today is the Tacoma Narrows Bridge, but it didn't always look like this. In fact, it once looked like this. For all the destruction, there was only one fatality, a three-legged Cocker Spaniel named Tubby. When the bridge collapsed, he was still inside his car and went down with the bridge. Where is the car and where is Tubby? These are two of the biggest mysteries of the bridge today. On the morning of November 7th, 1940, the Tacoma Narrows Bridge violently shook itself apart and sank into the ocean. What's so amazing is that they knew it was going to be a possibility and had time to warn everyone. Meteorologists in the area could see the low-pressure system moving in south of the Tacoma Narrows Bridge and advised that the wind conditions could be dangerous for a bridge that they already knew had a tendency to undulate up and down. Everybody knew that the Tacoma Narrows Bridge, or Galloping Gertie as they called her, could oscillate up and down. That wasn't new knowledge. But nobody knew that she would behave the way that she did on November 7th.
Wave or the Galloping would start. You'd be driving along and there'd be a car 40 or 50 yards ahead of you, and it would disappear in the valley of the waves. And then when you'd come back up on the crest, you'd see the car again, and it was a very weird sensation going across.
Realizing the unique proportions of the bridge, authorities appropriated $20,000 for a study by Professor Farquharson of the University of Washington. His simulated wind tests put a scale model of the bridge under a series of stress tests by duplicating all of the known modes of undulation the bridge experienced. However, on November 7th, 1940, the movement changed. It went from a simple up and down wave-like motion to one of severe twisting.
And this is where things get interesting. So what is even happening here with this new twisting motion?
What finally brought Gertie down was a phenomenon known as vortex shedding. Simply stated, it's a principle of aerodynamics that says when the wind is interrupted by an object, in this case these solid bridge sidewalls, eddies are formed which can cause vibration in the object. In his effort to reduce cost of the building of the Narrows Bridge, Mosef had substituted flat plate sidewalls in place of the open trusses recommended in the original design submitted by the state. These sidewalls, in combination with the flutter of the bridge deck, produced the violent twisting oscillations which caused the bridge to fall. Surprisingly, the Narrows Bridge as she stands today looks much like Clark Eldridge's original designs.
You can see a really good example of vortex shedding with this simulation here, which shows either a liquid or air moving past a stable object. Those eddies that flare out like a tail are what cause movement. A great example is the movement of lampposts under the perfect wind conditions. And the perfect wind conditions might not be what you expect. There actually needs to be a low enough wind speed for low pressure pockets to be created on either side of the object. It's those low pressure pockets that push the object one direction, causing it to actually increase the vortices on the other side, pushing it backwards. The day of its collapse, the Tacoma Narrows Bridge did experience undulation from vortex shedding, but not enough to destroy it. What really put the nail in the coffin? Aeroelastic flutter, or the bridge's tendency to amplify the vortices. In short, once the bridge started to twist side to side, it would actually catch the wind, creating larger vortices in an ever-increasing method that eventually caused it to twist itself apart. By saving money and not including open trusses on the bottom of the bridge like they have today, the closed sides actually made these perfect scoops that allowed for the bridge to catch vortices and then fling itself to a larger scoop, creating ever larger vortices the more it oscillated back and forth. So while it would be easy to put all of the blame on the storm that struck November 7th, 1940, it really wouldn't be fair. The real blame lands on the engineering of the bridge and not allowing the wind to move underneath the bridge sufficiently enough that it didn't just destroy itself. When you look at the models for vortex shedding, divers today continue to use those models as a basis to look for the car and the remains of Tubby today. After all these years, neither have ever been found. But the mystery continues to pull people down to the depths of the Tacoma Narrows Bridge. That storm, however, did continue on a track across the country, and by the time it reached the Great Lakes, it had truly developed into a magnificent storm that destroyed several parts of Chicago. So what's the takeaway? Well, check the weather, do your homework, and don't cut costs on your bridge.